yesterday we were talking about the states of matter and the changes of matter, how the different ways, like characteristics that those different states of matter have, how we change from one to the other, what a curve of changing from one state of matter to the other looks like with that heating curve. Today, we're going to talk a little bit more generally about the properties of matter itself. As always, I'm making sure to record this meeting. So once we're done for a class this evening, I'll make sure to post the recording right here in our class recordings section of the Google Classroom. So like I said, today we're going to be talking about chemical and physical properties and changes of matter. So what does it look like when we're measuring or looking at or thinking about the properties of a substance? And how do we define it when that substance changes either in form or in matter? So what we're going to be talking about today can kind of be broken out into 4 different categories. There are physical properties and physical changes, which are the first couple things that we're going to be talking about. And then we're going to use that to kind of springboard into chemical changes and chemical property. These are all really similar ideas to each other, especially the 2 different types of properties and the 2 different types of changes, but they differ from one another in a couple really key important ways that we're going to be going over as part of our notes this evening. So up first, we have our physical properties. So a physical property is a characteristic of a substance that you can observe or measure. So what we mean by this is an observation is something that you can make with your 5 senses, either looking at it, feeling it, smelling it, tasting it even, or hearing it. These are all observations that we can make about the world around us. And so the physical property of an object is something that we can observe about that object. So a lot of the initial observations that you might think of involve sight, because as humans, we're very sight and vision oriented. That's kind of our go-to way of navigating our world. And so things like how big something is, what something is made out of, what color it is, all those would be physical properties of a substance. So things like color and size, things that you can see, the state that an object is in, so whether it is a solid or a gas or a liquid, that is a physical property of that substance. And then also things that you can measure. So not only how big that something is, but also how heavy that it is, its mass, and how dense that a substance is. These are things that we can measure about our matter, our substances, and observe about their physical properties. So anything that you can measure or look at or touch or taste or smell about an object, that is its physical properties. So like I said, the state of a piece of matter and that phase change temperature, so the fact that water, if it's liquid, if you change it to 0 degrees Celsius, it'll start freezing. That is a physical property of water, its freezing point. This metal over here is very shiny, and if you touched it, it would feel very smooth. If you picked it up, it would be very heavy. If you felt it, it would be very hard, right? All of those are physical properties, things that we can physically observe and see or measure about these chunks of metal right here. So again, not only sight, but also touch and Even if you like dropped it on the ground and it made a big like metallic clang, that would be a physical property of our metal. Our little water bottle over here is made out of plastic, as most water bottles are. And the plastic used in water bottles, one of its physical properties is that it is see-through. So if I put my hand underneath that water bottle, I'd be able to stare through the plastic and see my hand on the other side. Because the plastic is see-through, you can see right through it to any objects that are underneath it. So that is a physical property of this water bottle. We can see that it is transparent, that it doesn't block our vision. We can see right through it. Also, if you took this water bottle in your hand, you'd feel that the plastic on water bottles is usually really thin. So it's super easy to like squish down flat or like crunch up short or kind of squish around. That is another physical property of this plastic. Again, things that we can feel when we touch it. And then another final good example over here, this piece of fruit is very rotten. If you smelled it, it would have a really gross, probably sticky sweet smell. If you tasted it, I'm sure it tastes really nasty. So those are all physical properties of this piece of fruit. Even if you were blindfolded or somebody put their hands in front of your eyes, if they gave you a piece of fruit, you'd be able to hold it up to your nose or taste it a bit and tell, oh man, that is gross, that is rank. Something is very, very wrong with it. I don't even know if this used to be a peach or an apple. Whatever it used to be, it is not that anymore. It's real gross and nasty. So the bad smell and the bad taste are physical properties that most rotting fruit has, right? Most fruit, if it goes really bad, then you can tell pretty easily that it is really nasty. All right. Hey, Jessica. Hey, Juanita. Hey, Jonathan. Good to see you guys. Thanks for joining up. All right. So these are all physical properties, things that we can observe about these objects. This water is a solid. This metal is heavy and smooth and hard. This water bottle is see-through and crunchy and squishy. And this fruit smells bad and tastes bad. So these are all properties of these objects, things that we can describe about them. But what about if we changed up how these things looked? So this metal over here looks like maybe it was one big piece at some point, but then somebody either dropped it on the ground or hit it with something or cut it with something, and it got separated into these like 3 smaller pieces. So if a substance goes through that kind of transformation, that is called a physical change. So in a physical change, we have a substance, we change how it looks, but at the end, we still have that same substance. So the form of our substance changes. Our piece of metal used to be one really big hunk of metal, but then we broke it up and cut it up into smaller pieces. However, we did not change the identity of the metal. It started off as metal. We broke it up into pieces, but those pieces are still metal. They're still these big metallic chunks of matter. So that's what we mean when we talk about physical changes. These are things where we might change how a substance looks or how big or how small it is, but it is still the same chemicals. It is still the same matter at the start as it was at the end. So the properties remain the same. Those physical properties are going to be the same. Maybe some of the things like the mass might change, but how it looks should still be the same. How it smells should be the same. How it tastes should be the same. It's just that we changed it from one form into another. It's like if you had one full apple and then you took your little peeler or your knife and you cut up a whole bunch of different little slices. All those slices are still apple, right? They didn't change into some new fruit when you cut them off the original piece. You just changed their form. You made one big apple into a bunch of little slices of apples. So melting is another example of a physical change, because we start off with one block of solid material like an ice cube, and if it melts into water on your table, and then you have a little puddle of water sitting on the table, the water that was in the ice and the water that's on your table are the same chemical, right? It's the same substance. Just before, it was solid water, and now it's liquid water. So same substance but different form means a physical change. Same thing with like if you dissolve something, like so you have some coffee in the morning and it doesn't really taste that great, so you add some sugar into it and you stir it around. It looks like the sugar molecules disappear, right? There used to be these little clumps of white sugar, but now they're gone. But when you taste your coffee, you can still taste the sweetness of the sugar. Or if you like me, I don't really like coffee, so I put a lot of sugar in there so that I can taste more sugar than coffee. So the sugar is still there, right? You can taste it when you drink your coffee in the morning. But we just changed its size. Before, it used to be these kind of big sugar crystals, and now we dissolved it and turned it into tiny, tiny little microscopic sugar crystals. But they're still in there, and that is what is causing your coffee to be sweet when you add the sugar. Same thing, shredding is a really good basic example. Like if I took a piece of paper and shredded it all up into like confetti, all those little tiny pieces would still be paper. It'd still be made out of the exact same stuff as our original piece of paper. We just changed the form. We changed how it looks a little bit. So some other good examples of physical changes with this wood chipper right here, right? You're clearing out some brush from the yard, or like what I had happen about a week ago. I live in Cedar Park, and so they're having a Christmas tree drop off in the parking lot of the rec center. So people could bring their old Christmas trees, like their live trees that they had in their house, and they stick them through a big wood chipper like this one. And so that's what I did, and it was super helpful because I just drove up with my old dead Christmas tree in the back of my trunk, and then I pulled up next to it, and these two guys opened the trunk and just pulled the tree out, closed the trunk, and then put it through this wood chipper. So just like with my Christmas tree, this piece of tree right here is going in as one big piece of wood into this dangerous choppy part of the wood chipper and shooting out as millions of tiny pieces of wood on the other side. So normally we'd call this like sawdust or wood chips or something like that, but it's still the same wood as went in over here, right? It didn't magically change into something new and different inside of the wood chipper. It's the same material, just in smaller pieces. We changed it from one big solid piece of wood to millions of tiny floating pieces of wood. Over here, we have a pot that is boiling on the stove. So I have a whole bunch of water that is vaporizing and turning from a liquid to a gas. So the liquid that is in this pot is water, and the vapor that is coming off the top of the pot is water. So we have a physical change here. We're going from liquid to gas, but it's still water. All right, this liquid is water, this gas is water. It's just changed states. We've gone from one state to another, a liquid to a gas. So we didn't change the substance, we didn't change the chemicals, we just moved the particles in them a little bit further apart. So that's why this is a physical change. We started off with water, we ended with water. We just changed the state that that water is in. And then finally, like I was talking about, if you dissolve something in water, like, I don't know if your guys ever had parents who did this, but when I was younger and I had like a sore throat or something, my mom would make us gargle salt water in order to make it better somehow. I don't even know if it really works, but she made us do it. And it was gross and it was nasty because it tastes like you're putting a whole bunch of seawater into your mouth, and then you got to keep it there and gurgle it around for a couple seconds. Not pleasant. I would not recommend doing it if you don't have to. But the reason why the water tasted salty is that the salt got poured in and then swirled around until it dissolved. But the salt is still in there. It's making the taste of the water change. So the salt just went from big crystals down to microscopic particles. But it didn't change into something different, right? The salt didn't magically make this water taste like Pepsi, which would have been something. It just tasted like salty water because the salt went through a physical change. It got changed from a big salt crystal into a teeny, teeny, tiny salt molecule. But it's still salt. It still has that salty taste, which is why it flavors the water that way. We didn't change the substance itself. We just changed its shape or its form. All right. Anybody have any questions so far on physical properties or physical changes?
No.
No, thank you. No.
All right, great. Thanks, Juanita and Seema. It doesn't sound like anybody else has any pressing questions either. So the next thing that we're going to talk about is kind of the opposite of physical changes. So remember, physical change, starting off with one substance, changing how it looks, but ending with the same substance. Our next case, we'll look at what happens if we start and end with different matter, different substances. So that kind of change we call a chemical change. So in a chemical change, we change the identity of the substance. We start off with one substance, but then we change it into something new, something different, something that was not there before. So that's what makes this different from a physical change, is because this time we are actually changing the matter that we have. So whatever this new matter is, it's going to have new physical and chemical properties, right? Because it's not the same as what we started with. It's something new. It's something different. It's something that was changed into something new. So there are some different signs if you're looking at some sort of reaction that it is a chemical change that is going on. So if the color changes, and I don't mean like if you have some water and you pour in some purple Kool-Aid mix and then the water changes to purple. I'm talking more about if you have something that is green, but then it turns to brown, or if you have something like you combine two clear liquids and then all of a sudden it turns blue, that kind of color change would indicate that a chemical change is happening, that you have some sort of new substance in there that's a different color from the original substances. If a gas or a solid is formed, that could be a sign that a chemical change is happening. So like if you guys have ever seen like the classic kids science fair experiment of the volcano, where they combine vinegar and baking soda, and then all of a sudden this like big bubbly mess starts coming out the top.
Yeah.
Those bubbles are happening because the baking soda and vinegar are chemically changing into new substances, one of which is a gas. So you have this gas being given off, and that's what's causing all of this bubbling in that solution, in those chemicals. Also, if something starts giving off heat or light while it's going through a reaction, that is a good sign that you have a chemical change as well. So for example, if something is burning or combustion is a classic example of a chemical change. You start off with like a match, right? That's just kind of sitting there. And then you strike it against the matchbox and all of a sudden it catches on fire. It starts to get hot at the end. There's the little flame that's dancing around on the tip of your match. There's a little bit of smoke that's coming up off the top, so some gas is being created. And then at the end of it, that match, if you let it like burn all the way down, that match turns into this little black pile of ashes. So the solid wood match has now changed into smoke that went up into the air and ashes that are now sitting in front of you. So it went from a match into something different, something new. The identity of the match changed. Resting is another good example. So burning, we were just talking about whether that is like logs or sticks, whether that's matches, whether that's burning like inside of a car engine. You burn gasoline in order to make the car go. The gasoline is what actually burns and gets lit on fire essentially for a brief split second. And then what comes out of your exhaust is gases like carbon monoxide and carbon dioxide and water. And so hopefully there's no gasoline coming out of your exhaust. That would be a very bad sign. But the reason why all those gases are coming out is because when the gasoline burns, it is chemically changed into new substances, which include those gases that come out of your exhaust pipe. Rust is another great example of a chemical change. So this is a good example of a color change, right? We start off with these nice silver shiny iron links in whatever sort of chain this was. And then over time, the iron and the oxygen in the air slowly react with one another and form a new substance called iron oxide, which is this brown, flaky, gross stuff that forms on top of metal. So the rust is a new chemical that was formed by the reaction of these two chemicals that were there, the iron and the oxygen. So we get this new color, the texture changes, right? It becomes really flaky and kind of crumbly. And that is all due to that chemical change. So the iron and the oxygen become chemically changed into iron oxide, which has different properties than the original iron. And then like I was saying with the gas formation, you could do the grade school volcano. Also even something simple as like an Alka-Seltzer tablet, like the old school medicine for like heartburn and indigestion and stuff like that. When the tablet drops into the water, the coating on the tablet and the water molecules go through lots of chemical changes. And one of those produces all of this gas inside of your cup. So all these little bubbles that form and fizz up at the top of your cup, this is all gas being released by the chemical change between the water and the Alka-Seltzer tablet. So this gas is a new chemical being formed that was not there before. We have a chemical change between the tablet and the water, and that gives us this gas. So again, chemical changes are all about starting off with one set of substances and ending up with something new, something different, producing something that was not there before. So physical change, you start and end with the same thing. It just changes how it looks. Chemical change, your ending products are different. They are different chemicals, different substances from your original material. All right, so lastly, if we want to describe what sort of chemical change that a substance is going to be going through, that is its chemical property. So a chemical property is essentially how likely a substance will undergo a type of chemical change. So for example, things like flammability, stuff like wood and gasoline and propane, they all share the chemical property of being very, very flammable. it's very easy to light those things on fire. On the other hand, something made out of metal, like my water cup here, it is not very flammable. So one of its chemical properties is that it has a very low flammability. It's very hard to get something to made out of metal to light on fire. It doesn't really happen that way. So if something is very flammable or not flammable, that's one example of a chemical property. If something is very volatile, meaning that it's very easy to react with the air and give off chemicals into the air, that's another chemical property. If a substance is very reactive, meaning that it will very easily go through chemical reactions if you combine it with some other substance, some other material, that's another chemical property. So some substances are extremely reactive. They will explosively react when you mix them with even something as simple as like water or air. They'll very explosively react. Other substances, other matter is very, very unreactive. It's very difficult to get it to do any sort of chemical reaction with any other material, any other substance. So that would be a chemical property of a substance. It's either very, very reactive or it's very unreactive, or maybe it's somewhere in the middle. So a chemical property essentially is just describing how likely will this material go through this certain chemical change. Is it very flammable? Is it not very reactive? Is it not very flammable? Is it very reactive? There are a lot of other different chemical properties that are out there. Those are just kind of a couple examples. So chemical property, will something go through a chemical change? If it does, that chemical change means that we start off with one set of substances, but end up with something new, something different that wasn't really there before. If we don't do that, if we take our substance and change up how it looks, but we still have the same chemicals, the same substance at the end of the process, it's only gone through a physical change, not a chemical change. And if we start describing a substance, if we start measuring its size and looking at its color and talking about how it feels and how it smells and tastes, those are all physical properties of a substance. When it melts, when it boils, physical properties, things that we can use to describe the characteristics of a material. All right, so those are kind of the four categories of descriptions of matter that I wanted to make sure to hit with you guys today. Does anybody have any questions about any of these four categories? Anything about any one of these that you want me to go back and describe a little bit more?
No, I'm good on my end.
For me, Mr. Michael.
Yeah.
Just like the last one, chemical change and chemical property. Those one, it's still. Thank you.
All right, no problem. So our chemical changes are when we start off with one substance or one set of substances, and then they go through some sort of reaction together to create something new. And so maybe something is burning. And so it started off as a piece of wood, but it gives off a lot of smoke and it gets turned into ashes. That smoke and those ashes are different substances, they're different chemicals than the wood that we started with. So that would be a chemical change. Same thing like with the Alka-Seltzer example that was mentioned earlier. If you just had this water glass and this tablet on its own, nothing would be happening. But when you add the tablet to the water, all of this gas starts to form. this gas wasn't there before. It wasn't a gas that was present before. It's only being created because of the combination of the pill and the water. So if we start off with two things, but now we're making something new, something different, that means that it's a chemical change. So chemical changes are all about producing new chemicals that were not there before. So like the rust that's on these iron links, right here, this brownish flaky stuff, that is a new chemical, a new substance that was not there before. It used to just be nice, clean, bright, shiny silver metallic iron. But over time, it reacts with the oxygen and creates this brown rust, this iron oxide. So because something new is being created that wasn't there before, that means that it's a chemical change that is happening. So a chemical property is just a description of a substance that tells us if it is likely to go through one of those chemical changes. So like our physical properties that we were talking about earlier were things like color and texture and weight and density and size. Chemical properties would be things like, is this flammable? Is this likely to rust? Is this very reactive with other chemicals? Is this very likely to be volatile, to go up into the air? All of those are chemical properties. So they're still descriptions of the material. There's still ways that we can describe the material, but specifically, it's descriptions about the chemical changes that the material is either easy to go through or not very likely to go through.
Okay, thank you so much. Now it's
No worries. It's what I am here for. All right. So there we go. The assignment that goes with the notes for today is a little bit long, but pretty easy to answer all the questions. It's essentially a couple different lists where you have to identify, is this a chemical or physical property, or is this a chemical and physical change? So it starts off with a little kind of description again of what are physical properties and chemical properties. And then the first part asks you to imagine a piece of wood and write down 3 physical properties that you could observe about this wood and a likely chemical property of this piece of wood. So that's kind of the first part. There's a couple questions there. The next part is 10 questions long, and it's going to give you a whole bunch of different kind of scenarios or descriptions. And what I want you to do is tell me, do these describe a chemical property or a physical property? So for things like iron and glass and acid and copper, it'll tell you something about, it'll tell you a property of that material. And I want you to tell me, is it describing a chemical property or a physical property? So that's sort of the first set of questions. And then the last part, the next set of questions, has to do, instead of properties, now we're looking at changes. So whether or not it is a physical change or a chemical change. So just like before, same exact setup, only now instead of classifying properties, you're classifying changes. So this ice cube, these gases, the saltwater. They're all going through changes, and it's up to you to tell me, are they going through chemical changes or physical changes? And so you do that for this final set of kind of scenarios here. So that's the Google Form version. The Google Doc version, again, is the exact same questions, only instead of choosing the chemical or physical answer, it just gives you a whole bunch of these like blanks over here. And so you just have to write in, it actually might not let you mess with the blank. But you just have to write in either like P or C for each one. Chemical or physical. But again, it's the same set of properties and the same set of changes. Wait, hold on, let me fix that a little bit. There we go. All right. So that is what got posted as the assignment for today. Does anybody have any questions on the physical properties, chemical properties, physical changes, chemical changes, or the assignment, the Thursday assignment on figuring out which one goes with the described situation?
I have a question. I already turned in the homework. Can I resubmit it? Because there's some things I have questions. I need to change answers to.
Yep, for sure. I usually don't go in and grade the assignments until 1 or 2 days later. So yeah, if you tried out the homework earlier today, but want to go back and make some changes to it or resubmit a different version, you're more than welcome to.
Okay, thank you.
No worries. All right. Great question. Anybody else? Any other questions, concerns, things that you want me to clear up? All right, good to know, Jessica. Thanks. So as always, if you do ever have any questions about the notes or the homework or anything about this class so far, you can always reach out to me, shoot me an email, send me a text, leave a comment on the Google Classroom, and I will do my best to get back to you as quickly as possible. So like I said, a little bit shorter class for today. That's pretty much the main stuff that I wanted to cover with you guys to wrap up week 2 back here at the Excel Center in 2021.